So hello everybody and welcome back. This is Bernhard, aka FattyBull. You can find all my stuff at fattybull.com, and of course my project files, shaders, materials, models, whatever, scene files you want to call it, for free to download at fattybull.com. And of course check out my YouTube channel. So today I'm going to continue as I promised. I showed you last time basically in a live workshop in my live stream how I was setting up this scene file here with this wonderful Porsche, and how you can basically do the same in a very short period of time. And as I promised, I told you that I am going to really discuss today how you can create a glass material, but not just glass as you know it if you use a raster. No, this time I really would like to show you exactly how you can use glass and the refractive material, so to speak, when using ray tracing. So for that specific purpose, I have to take a little bit more time and go into material setups, and I have to explain a little bit more why most of the time it doesn't work out for the vast majority of all the 3D artists. And why a lot of people, even coming from old school ray tracing software packages like Mental Ray, V-Ray, you know, you name it, like offline renders, so to speak, and not real-time renders, why they are struggling. So especially in the automotive industry, you can also see here, you always need glass. And of course, best case scenario, if you have everything set up fully retraced, you also would like to have, maybe, depending on your scenario, of course, also your glass fully retraced if possible. So, but let's dive into this because there is much more to say, and I'm going to highlight the major points why it's not working for most of you. Let's jump into it. I start with a very, very basic material, and you know, new material in a folder. First of all, when you start with a new material, right? What is the first step you're usually doing? Usually you start with a color and you go in and you say like, hey, I start a color node, which is diffuse or whatever, that's a base color. Then you give it any color you want. In this particular case, we make it yellow. Then the next thing, and this is also, I'm going through the steps, also understanding the basics of a PBR shade and why it's so important. You need to understand it, that your retracing will work. Because if you do not understand this, you know, you will fiddle around, it will take you forever. So I can only encourage you, take this time here right now. You will not regret it, because that gives you the full fundamental basic knowledge of how to set up a basic PBR shader, physical based rendering or whatever. And as we know, of course, we have a base color. That could be also a texture map and so on. And then in all the other offline shaders and retraces, you also have metallic slot, which basically gives the shader the information how metal is it. It's a different fall off. Also how sharp the fall off is in terms of the reflection and in the code that is underneath, of course, this whole structure. But also what you can see is when I create here something, I push the one button on my keyboard, hold it down, click the left mouse button, and while you do that, you create a constant. A constant is nothing else than a node, a number, a value number in this case, but it's constant, so it's not really variable. And if you want to specify basically if this is metallic or if it's plastic, so metallic is metallic, metal or non-metallic, you can change here the value, and you can immediately see when you do that, right, it's the behavior of the shader is changing, and you can see that, aha, if this is 0, this behaves like plastic, and if it's 1, it behaves like metal. But also what you can see here not very clearly is, wait a minute, I'm missing something. I can't really see it in my viewport, so you create another basically constant and put it into the specularity and give it a value of 1. And the next basic value inside of a PBR material is, of course, roughness. Do the same. You press 1, click left mouse button, put it into the roughness slot. And as you can see, when you do that, when you set up those things, roughness is nothing else, basically also like reflection. Okay, so there is roughness and reflection, specularity or glossiness. However, those terms have been swapped out from old school ray tracers, okay, to new terms or different terms when PBR came out, and especially in runtime when we are talking about real-time ray tracing or real-time rendering in the game engine here. So you can clearly see, right, that the roughness value determines like how blurry your reflection is, how clean your reflection is. When you zoom in here, this is basically wrapped into an HDRI, and you can see a building inside. So if you change the roughness value to, let's say, 0.5, then you can clearly see how blurry this reflection gets, right? So if you make it, if you push it all down to 0, that means it's fully sharp reflective. That's about it. So those are the basics of any kind of shader. Now here's another misunderstanding. That's different from, let's say, if you compare it to V-Ray, to any other offline renders, right? You will not see this here instantly in the material viewport. And the reason why is this is also so crazy, right, that nobody really talks about it, is in this material viewport, you do not see anything retraced at all, even if you're setting up your scene file fully retraced. So if you're saying my reflection is retraced, my refraction I want to have retraced, it's not visible inside of your material editor. So this is in the viewport a preview, and for some reason Epic didn't like update this yet, or it's maybe in the work in progress, I don't know. But fact is, I will show you then the proof that this, what you can see here, is not retraced. Let's change the first value metallic, and I change this to 0. Now you see that the fall off is completely different from that material, right? And it looks like plastic. I also can make this color here a little bit darker. Let's do it maybe more in an orange that you can clearly see it. But you can clearly see the behavior from that material is changing. So you can see this is plastic right now, and if you change it to metal, you just push it up to value 1, and this is the strongest metal you can get. Very clearly, very nice to see. If I want to change now, of course, also my roughness, as you can see, I can slowly change those numbers in the blurriness, 0.1, 0.2, and you can see how sensitive those numbers are, because now see, look at, if you look closer here, the reflection of the environment is so blurry already that you can't even see it. So you have to understand that those values are very sensitive between 1 and 0, right? And it's really up to you what you would like to create. So those are the basics in that particular setup of a PBR shader. Now, of course, you can plug in now texture maps, what a PBR shader usually does, and you can change those numbers all the time in the parent material, which is, so to speak, under the hood. And now I want to show you something before we go even into opacity, before we go even into the refraction, because those basic material knowledge is what you need to know in order to move on. So now you see here, this is a material that was created with all those nodes, and that material, any change you are making in those nodes, it basically has to compile again. So what you do is, to move on quicker, is you create a so-called material instance. And that material instance, I just call it new material instance. There's nothing else I'm going to do. You can see here, that looks now a little bit different if you double click it, because then you can see, wait a minute, there are settings, I can see the preview, and I can see that there is a parent material, and this was the first material we created here, right? So, but in order to change this material, that this material is usable, as you might know from old school ray traced materials like V-Ray, Mental Ray, Arnold, and so on, it really doesn't matter. You actually never touch under the hood the node-based network. So what you're familiar with is most likely that you have already those values or slots set up, and then you can tweak them as you want. Hey, how strong is my metallic value? How strong is my specularity or roughness value? And then you make those proper adjustments to the material, assign it to the geometry, and you will see it once you click render, right? So in this particular case, I show you what you have to do that this instance, right, will have the same features, or you can use it the same way. So as you can see, I changed them, but I cannot access here the values. I cannot access my color, I cannot access my metallic, my specularity, my roughness. In my instance, it's not there. And the reason why you cannot access it, because you need to change it from a constant to a parameter. And how to do this is very, very simple. First of all, you can start here at the color slot, just right mouse click and say convert to parameter. So right mouse click and convert it to parameter. Then you can say this is my color. Now if you change this is now under the hood. Again, on top of it comes the instance, so to speak. Then you see it's automatically refreshing. After it compiled, you saved it, compiles it, and then you see, wait a minute, I got now in my instance material a color slot. That's the color, and now I can select it. And now look at this. If you change now the color, then you can the change in the color immediately, instantly, right? And this is super cool because this is how you set it up and how you build it up. But you need to understand how to build a parent too. So as you can see, the next values we would like to bring into parameters, for instance, here is convert to parameter, is my metallic value. So I do this, I click save. Now my constant becomes a parameter. I check my material, which is the instance, and all of a sudden you see, oh, here is metallic. So there's my number. And now you can play with the values here, and you can say like, okay, what's the value of my metalness, right? So you have also options here in the metalness that you can say, hey, there are sliders by default on the left. It's called material expression scalar parameters. Whew. So anyways, but you can see you can change here the factors or the values, and you can go in and say like my slider should maximum go to 1. So now you limit the range. Usually the value between 0 and 1 is anyways the maximum you can reach here. And so when you save it and update it, you can see here your slider will be stuck from 0 to 1, and it will not allow you to go any further. But those are basic setups, okay? But it's very, very important that you understand this, because the same procedure goes on for specularity. So you convert this, and then we say here, this is my spec. And then, of course, I have my roughness. So you change this and also put this to your roughness value. Now, if you save everything, now you have the first basic shader set up. You have to check that, and now you can control the metalness. Now it's plastic. Your roughness, I can make this completely flat. I mean, look at this, right? Well, look here the same. This would be a metal material, but the roughness is so flat, it's so blurry, right, that you can't even notice that this would be even metal because the reflection got blurred out so crazy, right? Now, once you know that, what is the next step if we are talking even about opacity? Before I even go into retracing, and let's keep in mind what you see here in the material preview, there is nothing retraced, okay? And the opacity, the glass material I'm going to show you, there will be nothing retraced in the material viewport, okay? It is definitely very, very important that you understand this. So let's keep that in mind. Now, what is the next step? The next step is that I would like to change in my parent material, of course, the opacity. And as you can see, opacity values, right, are very, very important, because otherwise, how could I make this transparent? But you see immediately here in the material, there is a problem, because if you would like to put in any constant value, first of all, into the opacity slot, I'm not even talking about the opacity mask, and even further down below the refraction, which we do ignore completely at the beginning, it's not active. That slot is not, active at this point. You cannot put in anything. You cannot put any data into this input. So how do you get this active? First of all, you select this material, and then in your material slot, you see under the material section, you have here the blend mode, and the blend mode needs to change. And how to do this is you go from blend mode opaque, you change it to translucent. So again, change it from blend mode opaque to translucent. Now, when you do that and you save this material, you see like, whoa, wait a minute, what happened now? That's super cool. My opacity slot got now active. But unfortunately, you lost your metallic, you lost the specularity, the roughness, and some other options, right? And that's what you don't want to do. So you don't want to have that. So what you have to do is, in order to bring also those values back, is you have to go back into the translucency field, column, call it whatever, or a tab, and then you see you also need to change the lighting mode. And right now it is as a standard, as a basic volumetric, non-directional, but you need to change this to surface translucency volume again. So you have to go down into the translucency tab, search for lighting mode, and change it to surface translucency volume. So when you do that, and you see also it's compiling again, and you click save, then you're finally at a point where you can say, oh, wait a minute, fantastic, I got my basic PBR slots, the options and features I need to create and craft and change my material, I got it back. So you can see there is base color, there is metallic, there is specularity, there is roughness, and we have now also the opacity open, including even the refraction. Even so, we don't need to talk about the refraction at all at this point. But this is what you are getting, right? Now, if we are going to assign this material now to a sphere, and we can do this here immediately. So I drag and drop here a sphere, and I select it, and I take my instant, okay, and nothing else. I use the instanced material. Then you can see how it looks. It looks exactly the same like in the material editor, in the material viewport. We have here the possibility to also create now a constant. So again, push the one button, left mouse click, drag and drop it into the opacity slot. And then when you do that, look what happens. And you can see, wait a minute, if I give now my glass material or my opaque material, the opacity value, the value of 0, that means it's completely invisible and there is nothing I can see. So if you are going to think about glass, right, or anything that is similar to glass that's completely transparent, you would actually see nothing like you see it here. Now to check if this is actually true, change the value to 0.5. It's exactly in the middle. It's semi-transparent, so to speak. And you can see, whoa, yeah, now I kind of get it, right? So this would be my glass material because, like, yeah, it looks like I can see through. But when you also closer observe now this material setup, you will realize that it just doesn't fly like that. It just doesn't look like glass. Especially when you look into the viewport looks completely different. But again, the reason why is, don't get confused about this. You can also see it here from the color, right? If you bring them close together, look at the difference here. There is, first of all, in the opacity refraction, you can clearly see the first issue is that the sky and the bottom is flipped. In the actual final editor, yes, in the viewport from the editor, right? So this is a problem. So this is the first problem. Look at the sky from the sphere, observe this, and you have to always check this and understand it. And then you see here the bridge and everything is upside down, right? So that's a huge problem. And second of all, it looks completely different, and here's already the first proof from the viewport. And the reason why is because from the material viewport, right? Because the material viewport is not set up for retracing, while the project settings and the game runtime retraced setup for this scene is already set up for retracing. When you look at this, you can clearly see, wait a minute, there is no match. That sucks. So how can we change this? What the hell is going on here, right? So before we go into this problem and before I'm going to reveal and show you what you need to consider, you first of all need also to understand what you can do here with the opacity, that the glass material looks before you even start retracing the glass. It looks kind of like okay. And as we can see here, this is not going to look like glass because glass behaves completely different. And what glass does usually is when you look at it and you have a sphere like that, you usually see more transparency in the center and you see less transparency on the edges. And this whole thing about like the angle, how you look at an object, has something to do with the fall-off curve. And that fall-off curve can be different, and depending on the material and the light is hitting it, there are different indexes of a fall-off. Now, the index of a fall-off can be different in the reflection, but it can be also different in the refraction, and that basically, those indexes, how the fall-off material behaves in the natural world, determines how this material will look like. Now, how can we see that? How can I change basically this fall off and to see like what is going on? First, before we go back into the opacity and we look at how transparency works, I want to show you how this fall off, right, can be influenced and set up, and you need to do this all the time, in your parent material, because if you set up here a parent material for PBR shaders, that's what you need to use further on and on for all the other instances. So the fall off basically can be built with a so-called lerp. Now if you push the button L and then left mouse button, then you can see here is a lerp, and the lerp node is nothing else than a fall off or like a blend between two different values that you can specify. And I'll show you how we can do this very, very easy. So what I can do is I can create here, now you know how to create a color. I create another color node. And yes, I do it. Unfortunately, you know, it's not called color. When you try to create a color node under the hood, this node is called constant 3 vector. Okay, so when you create this, you can say, you know what, my first color, and let's, I don't know, let's do this here, blue. I'm going to create this blue. Then you start another one, right? And then you type in constant 3 vector. You could also copy it. And then you say, my second one is maybe green. Okay, so like this, something around here. And now what you can do is in the lerp, and I basically ignore now this other setup, you can go into the color from your blue and drag it into your first input of your lerp. It's basically A. And then the second one is B. And then what I also do is here, because remember you want to keep this also then in your instance, not as a constant, you want to have it set to a parameter, you convert it to a parameter. And then I can call this inner color. And then the second one, which is here, I also convert to a parameter and I call it outer color. Okay, so now when you do that, right, there is another node you need to understand, and this is in order to create a fall off. And this is what I'm trying to show you here first visually with color nodes. Okay, that I said before, you know, I was talking about a fall off. That means when you look at this sphere, the color in the center might look different than on the edges. It's a natural fall off. So what you can do now is you need to make sure, and this is what I'm trying to show you here, that you can blend between those two colors or those two edges or the fall off, the perspective you're looking at in a specific angle, right? You specify. And there is also a name for that, or a node, and it's called Fresnel. In Germany, we said many times Fresnel. In French, you probably say Fresnel, right? So, and here in the US, whatever you call it, Fresnel. But that's nothing else than a node that also tells you, look, how can I basically influence this whole characteristics blending from the outer side to the inner side, okay, when you look at an object. So, and in order to do that, what you do is you create here another constant, and again push the button 1, left mouse click, we have another constant. And then what you do is you bring this into exponent in, okay? Okay, so let me zoom in here a little bit that you can see this better. So just focus on that here. Then you can see the lerp is nothing else, as I said before, like the blend, and you go from the inner color to an outer color. So the inner color would be then here the center of this object, of the sphere. The outer color would be the fall off on the outer side. Now the Fresnel is basically the node that is helping you to create this, and you have also here a so-called constant again that is connecting with this node. So what I have to do is just select here the Fresnel, drag and drop into the alpha, and then once this is done, what we exchange now is we unlink, break this link here. Okay, so break all the pins, and then bring in the lerp into the base color. Now when you do that, and when you look at your final output, then you can see, wait a minute, there is something happening. And what you can see, what's really happening is there is a color change and color shift. Now what I do is, to show you that much better, I take the opacity value and push it back basically to 1. And 1 means there is no opacity at all. And what you can see now, look at those colors, right? And let's save this here, that we also have to set up. The inner color is a parameter, the outer color is a parameter, and we specified also here a Fresnel value. But this Fresnel value is still basically a constant. So you want to change this also to a parameter, and let's call it Fresnel, because this is influencing then our fall off. Now, when we save, click save, and we look now into our viewport, and then we open also our instanced, let's close all the other materials here, and we open then also our material instance, you can see again it looks perfect. It looks now exactly how it's also in the viewport, and in the instant material we can change now also the Fresnel. And look at this. Now you want to have a closer look. What is happening with this crazy curve, right? So look at this. That basically is now the blend value you specified, or in the setup. You can now control how strong this fall off curve is from the center right to the outside. Now what you can also do is you can basically go in and can say, I want to change my roughness to see this fall off curve, exactly how I can control it. So you see you can go from completely green to blue in the center, and then you push it so far out to the edges that you can control those values. It's nothing else than a fall off from the center again that curves around this sphere. Now when you do understand that, and the reason why I show you this here is, first of all, because materials like metal or whatever, a metallic car shader behaves similar. So it's not just flat, it's not just where you have one solid color. This would be usually paint. But if you are in the automotive industry and you want to create somehow a fall off, then you have two colors. And let's say you have now a red color in the center, and on the outer side the fall off could be the same red but darker, and it usually shifts much more into the black areas. So when you look at this and you go now back, then you can see that this metal in the fall off looks finally actually much better, because it simulates this effect just in the color slot. I'm not talking about here in the fall off in the reflection, because you can do the same of course in the reflection. That's a major part. That's where the index of reflection comes in, and this is how you can control it, because you can then go in there and change this in the reflection as well. But for this particular case, remember, we are talking about how do we set up a retraced material for refraction. That means glass. How can I do this? Now, why did I show you that? Why is this lerp and this Fresnel fall off now so important for the glass? Well, let's go back here. I need to apply the same principle to the opacity. This is so important. And now what I do is, let's do the following. I just make this blue, drag and drop it, forget about the lerp here. I just take the color value and I don't have any fall off so that you can see it better. And what you can do now is you basically recreate the lerp node, what you see here, from again the fall off from the center to the edges, right? And you create a new Fresnel, a new fall off, because you want to say, wait a minute, my glass material is more transparent in the center, but as more as it crawls to the edges of the sphere, it gets more solid or more visible, right? So you need a Fresnel fall off. How to do so? Just copy the lerp, the Fresnel, or create a new one. It's totally up to you. I recommend anyways, usually create, if you start from scratch with something, start creating it, because it's a good training tool. And then you can say, okay, press the L button, left mouse click, and you have your lerp. So Fresnel, right mouse click, type it in Fresnel. And because you want to create, again, two parameters in the opacity, and you want to mix and blend between A and B, center and the edges. Okay, so and the next step you want to create is here, of course, again, a constant at the beginning, and you say like, I want to blend as a 1. You can convert that constant here again immediately into a parameter, and now call it Fresnel and underscore opacity. Okay, so that you know what Fresnel you are influencing. And what is the next? The next is that you only need basically 2 values from the center and to the edges. So you create, again, press the 1 button, to constant, change it to parameters, and call it here again. This is my inner opacity value, and I name it so that you really know what you're doing. Okay, you can rename this, of course, and then you can say this is my outer opacity value, that you understand, okay, what is this thing doing, where is it going. Now watch this, because it's getting very, very interesting. If you change now and unlink this one constant, one value we pushed into the opacity slot, and exchange it now with this, you can basically influence immediately the opacity from the center to the edges. Now everything is set to 0, because look, the inner opacity is set to 0 and the outer opacity is set to 0. And that is nothing else right now than it would be, everything would be set to 0. But watch this. If you change, for instance, the outer opacity here, this value, let's say to 1 as a default value when you start creating the shader, and material opacity, now you see what it's doing to your sphere and to your glass material. And now you see in an instant the difference, because this feels like, hey, this is glass. This looks like exactly how I want it, because, you know, through the fall off curve, you can, of course, control here in the Fresnel fall off, you can change that. Now, the funny part is, of course, when you look at your material, which is here, let's save everything. Let's be clear here, and also let's save then the instances and everything. You might freak out, because you will say, wait a minute, look at this, Bernhard. Like, first of all, my parent material we created is bluish. But then you can also see in the viewport, in the preview viewport, right, it's red, which is the instance. And the material itself is, of course, blue. But when you also look and compare this now to your final render output in real time here, right next to the Porsche, it is anything else besides what we actually see here. And the reason why is this is a non-ray traced glass material, and we have been setting up the scene file to retrace it, right? But this material isn't ready yet to be retraced, as you can see. And again, on the flip side, what I wanted to show you, what I wanted to testify, to prove for you, you can clearly see here, look at this difference. This material viewport is never retraced, even if you have the retrace settings on in your project settings, because that's the material viewport, okay? And that's different from what you're actually rendering here. And that's causing a lot of confusion, I get this, but I'll get to this point. So now, what do we have to change and what do we have to understand now, because this is really getting awkward, right? So again, if you go back to the glass material, which is the instance material, you see that we have been overriding, first of all, the color. If you change this, and we have been also overriding here the roughness and so on. And if you undo that, if you undo all those values and you click save, you can see that it's definitely the case that the thumbnails, what you can see here, are exactly the same. And you can also see just in the material preview, this is the parent material, looks exactly the same than the material instance, right? So we are on something. It seems to be like this is the right way to go. And this is how you usually set up glass. But now, what do we have to do in order to make sure that this glass looks also good when it's refractive with retracing? So what do we have to understand here, and what do we have to change? All right. So one very, very important thing you have to understand as well is that any glass material that is set up here in Unreal needs to be set up for two-sided. And as you can see here, this is not the case, and you have to switch the button. This is the first most important step to do, that actually you see here then a change in the material, right? So if you do that, click it, and then you will see that the behavior is also changing here in the material preview, right? So you can clearly see, yeah, it's getting into a point where it looks more and more real. And when you click save, watch this, what's happening here on the sphere in the viewport, and watch this. It looks much better. It looks much closer now. But the same problem as I mentioned before, right? The sky is flipped. And this is a huge, huge problem. But it's totally perfect in the calculation from the shader. What is not supported here in this particular case, and in most of the cases, is actually the geometry. So, and I'll get to this point and I'll show you here in a minute. The same happened if you are familiar with old school ray tracers. In V-Ray, Mental Ray, Arnold, Redshift, it really doesn't matter, but you need to have the proper geometry support as well, because if this is missing, this is also going nowhere. But now with the two-sided material on, right, and I assigned here the instance material to this sphere, and to this sphere, and to this sphere, you can see that, okay, it looks like the refractive glass material, the refraction, is kind of like working, but we're still having this issue. Now, this comes back to what I mentioned before. You need to have the proper geometry support. And what does it mean? First of all, when I was downloading the Porsche model, which is a fantastic model, right? You can clearly see that the UVs and also the logo and the normal maps and everything is working out, because whoever did this model, and I mentioned his name already before and gave him all the credits, fantastic, and thank you so much. He did an awesome job. He knew what he was doing, so he was unwrapping this correctly, and he built it up that you have also the proper geometry support. But if you have a simple sphere like this, it's not working, it looks goofy because it's flipped. So what you need to do is you need to make sure that you have, if you're working with refractive, retraced materials, that you also have a shell or like a double-sided geometry. And here I opened for you 3ds Max to show you this, how simple this can be done. It doesn't matter what software you're using, Blender, Maya, Cinema 4D, you name it. But you see here, this is a simple sphere, a primitive object. You basically drag this and pull it up, and then you can see you have only one surface. And no other surfaces are facing in any other direction. And this sphere has actually, when you zoom in, right, you have an outer surface and you have an inner surface. You can also call it shell. In 3ds Max, it's actually really cool, because if you would pull up here a sphere, and just by showing you, and I isolate the sphere here, and there is a modifier in the modifier stack, and it's called shell, then you can add this shell, and you can say I want to have an outer shell. You can also specify how thick this is, and this would be the thickness of your glass. But you could also say, hey, I want to have it, I want to have an inner amount, right? But fact is, you have now double geometry that supports the glass refractive material. And if you don't have that, your glass material will not work. So this is also very, very important, because even when people created a really good glass material, then they said, look, it's not working. I checked even two-sided materials, but it all sucks. It's just all bad and blah, blah, blah. And I get it, because there are multiple steps you really have to consider that refractive glass is working for real-time ray tracing. So now let's check this here and see if it's really working. Look at those two spheres, what I have been creating. And you can clearly see I named it also here, right? You see the big difference. This one is basically shelled, okay? And then this sphere has no shell on it. So you see it here, shelled and no shell. And then you can see what I called out before. Let's do here my camera speed a little bit slower, that you can clearly see it. Look at the difference. Now we have the refraction kind of working in a way we want it to have it, and I can also control my transparency that goes through this. So you can clearly see here, if you go into your material, and now you have all the other options too, I can change now my so-called inner opacity and can say like, hey, I change this to 0, or I bring this further up with those crazy values. Oh, sorry, this is the Fresnel opacity in general. As you know, like how far do you want to push it, the Fresnel value. And then of course you can also change here now the inner opacity. Let's pull this up here that you can totally read it. So you have here the inner opacity, and it's completely gone. Or you can lower it, and now you can see the glass gets more and more transparent. You can push it so hardcore in the inner, right, that it's literally everywhere completely transparent. And you have, of course, also the outer opacity, because the outer ring is also what you can control. And now you have the full influence to control those values and change kind of the behavior of your glass. But one thing I wanted to show you is when you look also at the geometry from that Porsche model, right? I changed here the name of those assets. As you saw on my live stream, I was just merging them in using Datasmith. But what I did here was, you can see you have a front glass, and this is basically outside, and I renamed them with front, because when I turn those two glass materials or the mesh off, you can clearly see what's going on. So first of all, when you move this around here, right, you can clearly see, wait a minute, there is a glass shell that is outside of everything else, right? And then you can also see, when I undo this, that it's not just the shell that is outside, there is also one that is inside. And then underneath, you can also see that there is a material on it, and I created and changed this already before. That is metal. And when you look at this metal, this is also a parent material I created. It's a basic chrome shader, a metallic chrome shader, and it's completely reflective, and it's like chrome should behave. And what I want to highlight here is the following. You need to understand that if this stays black and you turn on your glass material, look how it is influencing the refraction, right? Because it's glass, it's transparent, and it's passing through. So it's correct, actually, what you see. But when you basically look at that black metal, you know. And when you go also to a front light from a car in the automotive industry, it's not really metal. It's usually something that is very, very plastic as well, right? When you ever opened kind of like those pieces inside of the front light, you will notice this isn't really metal. It's more like it's plastic or something in between. And now what you have to tweak is the material also behind the glass material, because when you have something that is refractive and it sees through, it has a complete strong impact to that, right? Because you see through the refraction. Now look at this. If you turn now on the glass material and you change here the metalness from the material that is underneath the glass, then you can see how you can also influence how dark it goes or how bright it goes, because it is, so to speak, the material behind that refractive glass material. And that's what you also have to adjust and what you have to understand. Next, what I want to show you is also how to set up this normal map. And the normal map is very, very simple. Here's our normal map. And what values do you need for a normal map to basically make it visible? Is again a new node, I guess, for you, but it's not as complex to set up a normal map. So this is called flatten normal, and you'll find it here under texturing. And then you drag and drop the RGB color into the normal flatten node. And with the flatness, guess what? You need to again press 1 for a constant value, push it into flatness, change that value to a parameter and call it intensity if you want to from your normal map. Or normal, let's call it normal intensity, that you always know like, okay, what is this parameter you are creating actually good for? So you do that, and then guess what? From the flatten normal, this is the setup. Again, normal map, normal intensity. You drag and drop this into your normal slot. So when this is done, yada, 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 look at this, beautiful, because whatever is visible here, and let's double click this, that you can see this. This is what you are going to see, the effect on the glass. And what you also can see is, obviously the artist who created it flipped those normals, because you can see the text from Bosch is of course flipped. The font is flipped, the numbers are flipped. Holy mother trucker, everything is flipped. And you will see like, okay, why did he do this, and what was the reason for, right? But I have to say, so when you look at the model, he considered it, however, he was unwrapping the geometry. I didn't check the geometry at all, right? You remember, I just brought it in straight through the Datasmith GLTF plugin, and he set it up correctly. So however he was unwrapping the glass material, he did a great job, because you can also see the normals have been then flipped with the UVs he created and the texture map. So this is all good. And if you change now the intensity value, and let's say you change this to 10, or use a crazy value by default, right? Now it's compiling it. You can see it gets much stronger, much more intense. But you can also go with the default at 0, save it. So it's compiling, and then look at the material instance, right? And then you can change those values here as well. And then you can clearly see, aha, this is how it looks. And also you can see here when you change all those values you're creating here in real time, you see exactly how the material looks in the parent material, which you can find here, right? So now we are getting to a point where you feel like, hey, this is great, because now I have full control about my general, look at this, Fresnel opacity, right? So how strong do you want to push this value? Then you have the inner opacity you can control. You have also the outer opacity you can control, okay? And you can create now your glass material as you wish. All right, so this was quite a lot, I get it. Now the next point And this is also what was for me very, very confusing, because we are still not done. There's still one point I need to explain. Even the shader is set up and everything is fine, but there is one point where a lot of people got confused. A lot of people didn't understand this, and I really want to show you that. Is that when this material is set up, this is now ready to go as a refraction material when using ray tracing. Check this. When I'm going to change now my specularity value in my instanced material, I don't see anything that is changing in my material viewport here. Nothing. You can clearly see, right? So I changed the numbers. It's crazy. There's nothing that is changing. And why is nothing changing? Because when I change my specularity, I should see something if it's refractive, retraced glass. The reason why is because in the material viewport, don't forget this, I mentioned it before many, many times, it's not a retraced viewport. It's cheating on you, right? So this is really, really bad. It's as bad as if your wife is cheating on you, your girlfriend. Like, then you have to throw up. I need to drink immediately. My shocker Red Bull. Holy shit. So, now, but if you look at this, I will be so pissed, and I am actually also, because if this is not working and somebody's cheating on me, and now my specularity doesn't work, what the hell, right? But now, wait. Before you freak out and go mad and buy a gun and kill everybody, I'm showing you here what is really going on. Because remember that the material viewport is not then the final result. The material viewport does not support the retraced material options. Holy cow. Now check this out. If you go now and bring it side by side, and remember, that's the same material we just created and instanced, and we assigned to the sphere that is non-shelled, and we assigned it to the sphere that is shelled. And we look at those at the same time while we are changing the specularity. This is the keyword, the specularity of this refractive material. That's so crazy. Look what is happening, right? Look. So you can actually see that in the values from 0 to 1, I'm getting a change. I'm definitely getting a change in the values from my IOR. And this is the so-called index of refraction. And it's crazy because you're not going to see this in the viewport here, okay, in your material editor. You only will see that. Again, look here, I'm going to change this very, very slowly in the actual editor, okay, of your final scene. And this is where it's, of course, the most important, because this is where you want to see it. Look at this. This is how you change the index of refraction, or IOR. Now, only if you're going to use it for a retraced version. Because if you want to use the non-retraced glass material, you can still use under the hood the so-called refraction slot. This is what it's built for. So this slot is working, but it's only working if you're using a glass material that is not going to be retraced. And this is where you plug in then the values for the IOR in the refraction for basically rastered glass. So when you use rastering and not retraced glass. And what is even more confusing then is, of course, when you look at the parameter from specularity, okay, this should be renamed if you use it for retraced version glass and call it refraction. So because when you call this now refraction, then you have it right set up, then it kind of makes sense, and then you understand like, okay, boy, this is it. Even so, when this is called refraction, IOR of refraction, whatever you want to call it, right? And it's nothing changing in the viewport, in the material viewport, so to speak. Don't get confused. It will impact the index of refraction, as you can see in your final shader. Holy cow, right? So the secret is revealed. It's definitely somehow something you need to get used to. Don't ask me why Epic was setting it up this way. It's definitely confusing, because like I would have never ever thought like, look, I'm controlling my index of refraction through the specularity. This is how you set it up. Whew, what a ride. So you can see it takes quite a lot of time to explain this, beginning from scratch and from start, that actually glass, if you want to use it as a retraced version, works for you. And this is just a material setup, and what you also have to do is very, very important, I didn't even cover it yet, is you need to set up, of course, in your settings, you need to make sure that you have ray tracing on if you want to have it fully retraced. And in your post-process volume, you need to check a few things. First of all, you need to check translucency. Okay, this is also very, very important, because if this isn't turned on, you have also a problem. And you can see it here. There is the type under translucency inside of your post-process volume. It's called ray tracing. And if you would change this to raster, look what's happening. The output looks completely different. So you want to change this back to ray tracing. So you want to make sure ray tracing is on. And then there is even one more thing that is important, because with the basic setups, you have a limited maximum refraction of rays. Usually, I think it starts with 1. And when you do that, you also see like the rays that are bouncing in between are not enough, because like if there's only one bounce just doesn't do it, because when glass has different shells and different objects like it has to go through, right, and it's bouncing through, you need to crank this up. Look, if you change now here the maximum refraction rays, let's say 2, it's getting brighter. Let's have a check here also on the front glass, on the front light from the Porsche. So let's change this to 3. Whoa, that does the trick already here. 3 looks already pretty cool, because it looks like it's going through 3 different shells or levels, and it's kind of hitting and bouncing me the last one back. Which kind of makes sense, because here we have really one outer shell, one outer glass material, then an inner, and then boom, it has to go through, bounces back, and you see the full refractive material, right? Now, as you can see, on this material that is not shelled, it would be enough, but this sphere is shelled, and it's not enough. So maybe you want to increase this to 4 or to 5. Okay? So this is also what you have to consider, and what you have to know, and what you have to, set up, also that the retraced translucency actually works. So I hope that this was useful for you guys, that I was explaining all the steps, what you need to do and what you have to set up, that the glass works with ray tracing. That is the most important, and that you can now create any kind of material you like to set up with the PBR version, and that you have the basics set up. And as always, you can of course download this scene file for free. You will find also my FattyBull basic materials in it that are reusable. And once you have this basic FattyBull material, which I showed you, you can reuse it for many other materials. It doesn't matter if it's wood, plastic, metal, etc., fabric even, because that's a standard PBR clean shader network that is not very complex. I have to say, so this is a very clean, non-complex, basic setup you can use. And finally, I wanted to see, of course, if you created texture maps using Substance or whatever, any other tool where you create texture maps. Like, all you have to do is you load those texture maps, and then you can create also those texture maps and parameters, change it to parameters, and use different texture maps and just swap it out, and that's what it is. So if you like that, of course, then please click thumbs up and please subscribe to my YouTube channel if you want to get more valuable videos. I will reveal much more, of course. And if you have not been downloading this project file, then feel free to do so right now from my website, fattybull.com/resources. You find there everything you can download for free. And that being said, I wish you already all the best. Happy pixeling and stay healthy, and talk to you later. Take care. Bye bye.